So right now we are reviewing for our exam, and we're reviewing for in our textbook, chapter 10. So vectors, polar coordinates, De Moivre's theorem, complex numbers. So in front of you is an example. So you should be able to plot a point in polar coordinates. We have the point here is -2 at 120 degrees. You should be able to do this in degrees and radians. So first thing that you want to do is look at our pole, and we're going to rotate our angle here of 120 degrees. So rotating our angle of 120 degrees gets us to this line. Our value of R is -2. So instead of heading the direction of that line, we're going to go in the opposite direction, and we're going to go down 2 circles. So this would be 1, 2. This would get us this point right here. So those lines that I was doing the angles and that vector is not the same. So that point is what we wanted. It wants us to convert the coordinates of the to rectangular form. Well, you can use some of the formulas, or you could create a triangle here. We know what R is, it's 2. We can figure out what our adjacent and opposite sides are. We know what our angle is because of that 120. Or we can use the form that, and we got this from the triangle, x is equal to r cosine theta, and y is equal to r sine theta. If we use this formula, then we can just plug in our coordinates of the polar coordinate they gave us. Our R value is -2, cosine of 120 degrees. So x is equal to -2, cosine of 120 degrees. Well, cosine, that's in the second quadrant, cosine is negative. Our reference angle is 60 degrees. So we would get back -1/2. So x here is equal to -2 times -1/2 is 1. So notice here, you can kind of see it on our picture that that length is 1. So let's look at the y value of our point. Plugging it in, we have y is equal to r -2 sine of 120 degrees. So y is equal to -2. Sine of 120 degrees, well, sine is positive in the second quadrant. Our reference angle is 60 degrees. And so sine of 60 degrees is √3/2. So in here, we get that our y value is, the 2's cancel, -√3. So the point of the rectangular coordinate is 1, -√3. Which is what we would get if we figured out what that opposite side of the angle was. And you should see that you would be falling in the same quadrant as the point of our polar coordinate. Part C says, let's give 2 other pairs of polar coordinates for this point, which would get you to the same spot. Okay, so instead of having R as negative and going across the pole, we could have R as positive. If that was the case, then we would need to rotate all the way over here. And that is -60 degrees. See in your directions, if they have any directions, like if they wanted your angle to be between 0 and 360 degrees, we would not use -60 degrees. We would use 300 degrees. Because I would be going in the same direction, I'm going to have +2, 300. If it didn't tell me my angle had to be positive, I could use -60 degrees. So to -60 degrees. So there's a lot of different answers that can vary here for this situation. The next example in front of us says convert 2x squared plus 2y squared equals 3 to its polar form. So recall r squared is equal to x squared plus y squared. We also have x is equal to, like we saw above in the last example, r cosine theta, and y is equal to r sine theta. So when you're converting these rectangular coordinate system equations into polar form, you are trying to look for things like this. So I notice I have a x squared plus y squared in here. I just need to factor out that 2. So if I factor out that 2, I would have 2 times the quantity x squared plus y squared is equal to 3. So this is 2 again, but x squared plus y squared we said was r squared equals 3. We could solve for r if we wanted. So divide both sides by 2. We get r squared equals 3/2. Taking the square root of both sides, we get r is equal to the square root of 3/2. Rationalizing our denominator, I can multiply by root 2 over root 2. So r in this case is equal to square root of 6 all over 2. So you should be able to go in the other direction. Given an equation in polar form, rewrite it in terms of rectangular form. So for example, let's say that you had r is equal to sine theta minus cosine theta. So notice in our equations that we put up here that r squared is equal to cosine squared plus, r squared is equal to x squared plus y squared. And x is equal to r cosine theta, y is equal to r cosine theta. So it would make our life easier if we could just go through and multiply both sides of our equation by r. And if we multiply both sides of our equation by r, we now have r squared is equal to r sine theta minus r cosine theta. Well, r squared is x squared plus y squared is equal to r sine theta, which is y, minus r cosine theta, which is x. I notice here that this is a circle. If they wanted me to graph this, this is how I would go about it. I would add x to both sides, so I get x squared plus x. I'm going to want to complete the square here. Plus y squared minus y. I'm going to want to complete the square for my y terms is equal to 0. Whenever I add it on the one side, I have to add on the other side. So the number that would complete the square here, adding what number to get back to itself 1 is 1/2. So 1/2 times 1/2, I would add 1/4 here. Half of -1 is -1/2. -1/2 times -1/2 is 1/4. So this is quantity squared is the same thing as x plus 1/2 quantity squared plus y minus 1/2 quantity squared equals 1/4 plus 1/4 is 2/4, which is 1/2. So if I had to graph this, this is a circle. The radius is equal to the square root of 1/2. Which is 1 over root 2, which is root 2 over 2. And the center HK, so -1/2 for the x value of my center and +1/2 for the y value of my center. So let's pull up another question. So it says if z is equal to -2 plus 2i and w, and these are vectors, is equal to 1 minus I root 3. Actually, it didn't say it was vectors, not vectors. Find the following and put your answer in trigonometric form. We also looked at exponential form of complex numbers. So I would want you to be able to do both. So let's put this in trigonometric form. Some books called polar form, trigonometric form. So this is put this in polar form. And it wanted us to figure out what A was. But let's first put these in polar form. So you should be able to put these in polar form. So put Z and W in polar form. So polar form, recall Z or W is R times the quantity cosine theta plus I sine theta. So let's plot Z. We have -2 for our real coordinate. So we're going to go to the left 2, and we have +2 for our imaginary coordinate. So we're going to go up 2. We can figure out what R is by making a triangle and using the Pythagorean theorem. So in this case for Z, R is equal to the square root of 2 squared plus 2 squared. So this is a square root of 4 plus 4, so square root of 8, which is 2 root 2. Let's graph W. W, my real part is 1, so I'm going to go to the right 1, and my imaginary part is -√3, so I'm going to go down √3. So I would get my point. I need to figure out what R is. I can create a triangle. So I know R is equal to the square root of my horizontal part, which was 1 quantity squared, plus my vertical part, which is -√3 quantity squared, or just √3 because I'm talking about a triangle. I get square root of 1 plus 3 underneath my radical. So square root of 4. So R in this case is equal to 2. We need to figure out what our angle is. So I'm going to call it theta sub R because I'm going to look at my reference angle first. My reference angle is contained for Z in quadrant 2. Okay, so how are we going to do this? We are going to look at tangent. I know that tangent theta is equal to opposite over adjacent. So 2 over 2, this is my reference angle. So I'm thinking about what angle of tangent would give me back 1, which is 45 degrees. But since I'm in quadrant 2, it's 180 degrees minus 45 degrees. So my theta value for Z is 125 degrees. 135 degrees. So for Z in polar form, this is equal to R, which is 2 root 2, cosine of 135 degrees, plus I sine of 135 degrees. W in polar form, well, we got to figure out what our angle is. Let's look at our reference angle. We know it's contained in quadrant 4. Tangent theta sub r is equal to opposite. So that would be √3 all over the adjacent, which is 1. So I know my theta sub r is 60 degrees, but I'm in the 4th quadrant, so 360 degrees minus 60 degrees. My theta for W is going to be 300 degrees. So W is equal to R, which is 2, all times the quantity cosine of our angle 300 degrees plus I sine of our angle of 300 degrees. So you should be able to now multiply these together, divide these together, find Z or W to some power. You should be able to find the root of these. And unfortunately, my time is up and I need to get down to campus so that I can be there for student hours. So go ahead and continue to study on that chapter 10 part. You have some homework that goes over that. You have the end of the chapter test that you're taking in the textbook. So that should give you some more review on this. And then you also have your end of the chapter My Math Lab test or My Lab and Mastering test that will be open both this weekend and next weekend that you need to do. And so that will also give you some more practice on chapter 10 material.